In this presentation, I will be comparing methods of predicting maximum oxygen uptake, also known as VO2 max, through the analysis of Courbet's article. VO2 max is the maximum rate of oxygen consumption measured during a period of incremental exercise. It is a frequently used measure of cardiorespiratory and aerobic fitness. The direct measure of VO2 max is both financially demanding and time-consuming. Additionally, it poses great health risks. Therefore, various predictive tests have been established in order to determine VO2 max. As I mentioned previously, VO2 max is used as a representative of oxygen consumption at a maximum effort. It is regularly used to assess the functions of central factors such as the blood, lungs, and heart, as well as peripheral factors such as skeletal muscles. VO2 max can evaluate endurance performance, specifically in relation to professional athletes. Therefore, through the comparison of various VO2 max predictive tests, we can determine the most effective way to predict VO2 max and thus enhance VO2 max measurements. The predictive tests that have been assessed in Courbet's study are the Cooper walk-run test, the multi-stage shuttle run test, and the submaximal cycle ergometer test. As shown in the table, these three tests have their own advantages and disadvantages. The Cooper walk-run test and the multi-stage shuttle run test can cater for large numbers of subjects simultaneously, and therefore are convenient. However, they require maximal effort and thus produce a potential health risk. Additionally, these tests require an exceptionally high degree of motivation to produce an accurately representative maximal effort. A submaximal test on a cycle ergometer does not depend on the subject's motivation or maximal efforts. However, it is time-consuming. These three tests were performed by 22 young healthy males with ages ranging from 19 to 29. The subjects had an average body mass of 72.4 kilograms. In the Cooper 12-minute walk-run test, the subjects ran for 12 minutes in pairs to induce motivation. A prediction of VO2 max was obtained from the distance covered at the end of the 12-minute period by applying the distance run to the Cooper regression equation shown below. The multi-stage progressive shuttle run test involves the subject sprinting between two lines which are 20 meters apart, with a sound signal indicating when the subject should start sprinting. The frequency of the sound signal increased every minute. The test was terminated when the subjects were no longer able to keep up with the set pace and did not successfully reach the targeted line on 3 successive occasions. The number of shuttles attained at the last level was recorded. The submaximal cycle ergometer test involves 3 continuous submaximal exercise sessions for a duration of 5 minutes on a Monarch cycle ergometer. Cycling was performed at an average of 60 revs per minute. Heart rates were measured within the 4th and 5th minutes using an ECG monitor, and expired air was collected within the final minute of each stage. The volume of expired air was determined using a Parkinson-Cowan volume meter. The VO2 max is predicted from these tests through the linear extrapolation of heart rate and VO2. This is achieved through the measurement of heart rate during given workloads and the extrapolation of those measurements to a predicted maximum heart rate in a linear formation to determine an estimate of VO2 max. The VO2 max predictions obtained from the subjects have been compared with the direct measurement of VO2 max from the same subjects on a treadmill. The direct measurement of VO2 max on the treadmill had an average of 60.1 milliliters per kilograms per minute. The results obtained from each predictive test are shown in the table. As you can see, the result attained from the Cooper walk-run test is very similar to the direct measurement, while the results from the MST and the submaximal cycle ergometer tests are substantially lower. These three figures show the correlation between each predictive test and the direct measurement of VO2 max on the treadmill. As you can see, Figure 1, which is the Cooper walk-run test, shows a very high correlation, while Figure 2 and 3 are lower. This is also expressed within the correlation coefficients in the table. The Cooper walk-run test has the highest correlation coefficient of 0.92, while the MST and submaximal cycle ergometer tests have a lower correlation coefficient. The findings from the study by Corbett suggest that, for the population assessed, the Cooper walk-run test is the best predictor of VO2 max out of the three predictive tests. The Cooper walk-run test measured a very similar VO2 max value to the treadmill value, which was the direct measurement of VO2 max, and this was reflected within its correlation coefficient. The multi-stage progressive shuttle run test and the submaximal cycle ergometer test showed a systemic underestimation of the treadmill value, which was also expressed in their correlation coefficients.